Hi, this is a reassessment video for position, velocity, and acceleration. We'll start off with question number 34, page 113, chapter 3. The track's length is 300 meters, going from a direction of south to north. So right here, we'll go ahead and R1 is our very first point, R2 being our second, R3 being our fourth, R4 R1 being our first, R2 being our second point of position, R3 being our third point of position, and R4 being our fourth point of position. Right here we have also 7.3 meters per second is the velocity on the first leg of the race. 7.2 meters per second is the second velocity of the race, the instantaneous velocity, as was the other one. 7.8 meters per second is the instantaneous velocity for that portion of the race. So we have velocity average. Velocity average is defined by velocity final minus velocity initial over the change in time. And since we have actually no displacement in the x direction, we're going to have x is going to be 0 the whole time. All displacement is going to be in the y direction. So we're going to go ahead and start calculating our displacements. Right here we got R2 minus R1. We go ahead and put it into x and y components. That leaves us with our x and y component, 0x hat y, 300y hat. We do the same thing on the next one. Try to make sure we can see this here. Alright. We do R3 minus R2. That gives us 0x hat plus 300y hat plus 0x hat minus 300y hat over time gives us 0 hat, x hat, 0y hat. Now, and likewise we did it with R4 to R3, and we have 100 y hat positive in the south to north direction of y, leaving us with right here 0x hat, 100y hat. Now, right here what we've done is we've gone ahead and demonstrated how these items cancel out. R2 cancels out with negative R2. R3 cancels out with negative R3, leaving us with R4 minus R1, which is ending position and initial position. Final position, initial position, so RF minus RI, and that's going to give us velocity average over the change in time. So we go individually and we go ahead and get our times for each of these situations. The first example, we get 41.1 seconds. Second example, we get 300 meters divided by 7.2 meters per second, gives you 41.7 seconds. And the final one, we get 12.8 seconds. We add all three of those times up, which comes out to 95.6 seconds over our total displacement, which is 100 y hat meters and 0x hat meters. So in the x direction we have 0 meters x hat. In the y direction we're going to have 1.04 meters per second y hat. So that's my reassessment. Have a nice day. Thank you.